All right, welcome to part 2 of simple circuits on the small breadboard. We have our 2 batteries in series aiding, so we got 3 volts available. We've got our lamp hanging out on a node, on 2 nodes here, just ready to be connected to. I mean, the pins are here and here. Of course, if we just take wires right to the lamp, we will have a complete circuit. Right, so we could experiment. We could do that just to prove that our batteries are good and that our lamp is good. Easily done, right? I mean, I'll take a wire to do this connection. There we go. That's one done. And another wire will do this connection for me to the 3 volts. There we go. So that proves everything out. Batteries and lamp are good. Let's try to add some other components, and I think maybe switches are a thing we could enter in here. So we did end the first video. We kind of left off with the fact that you just need to break open the circuit if you want to do switching. It's just that easy. Broke it open. I stopped the current. But I don't want to have to put a wire in and out and in and out. That's not what I'm looking for. I want an actual device that'll do that for me. So let's put a little push button there. The ones we have for you are these little guys here. So I can just put that on 2 nodes, right? I mean, it's a 2-pin device. Now notice where those nodes are. There's a node in between the 2, but maybe I'll just center that somewhere in something like that. And I simply bring my positive voltage to one side of the push button. And you know what? I'm going to move that push button down a little bit because that's easier for me to get my finger there. So positive 3 volts is coming to the one side of the push button, and I'm going to use a different color. I'm going to have my switched 3 volts, positive 3 volt side, and bring that to the lamp. I think that's it. Oops, that makes sense. So there it is. Now I just push the button, see if I did it right. Just like that. Now I can send Morse code by way of light signals. We have 2 push buttons. So, I mean, if I wanted to, I could put another one. And it doesn't matter where you break it open. That's sort of what I want to illustrate. I could break it open down here. I think you can see the way I've done it. If I put that in, I'm going to have to push both push buttons. This would be called AND logic. I have to push button 1 and button 2. Button 1 is switching the high side, the more positive side. Button 2 is going to be switching the low side, the negative side of the lamp. So wherever I want to put this, I don't know. Doesn't matter. I need another connection on the other side. So, you can play around with these kinds of things. Okay. Now pushing one button doesn't do anything, or the other button doesn't do anything, but I have to push both. And then it'll light up. That's it. I've got them ANDed together. I could OR them simply enough. If you put switches in series, they're ANDed. They both have to be pressed, one and the other one, to make it work. You could give them an ORed configuration where it's simply putting them in parallel, so that to create a path to turn on the lamp, I can press this button or this button or both. Let's see if we can do that. I'm going to bring the low side of the lamp to the 3 volt low side, but I'm still switching the high side here, and maybe I can get 2 of these on one node. That would be the simplest way to prove this. It's a little tight. It's a lot tight. I've got them OR'd. They're in parallel. I can press one button or the other or both. That's ORing. Yeah. And remember, it doesn't matter where I break the circuit open. I could break it open here, 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 anywhere. As long as I break open the path, I'll stop current from flowing and I'll have turned it off. Instead of a push button, I could use a slide switch that I have in my hands to open or close the circuit. A slide switch gets its name because it is just contacts that slide. When you push this to one side or the other, you're sliding a piece of metal to one end or the other. And I got some nice Sharpie beauty marks on my fingers, I see. You've got the slide switch. When it's to the right, it connects these two pins, the middle pin and the right side. Pretty obvious, right? When you slide it to the left, these two pins are connected. And it's probably worth mentioning, we'll look at a toggle switch sometime in a later video, and it's not so intuitive. It actually has a lever action. So when it's to the right, it connects the left contacts, and when it's to the left, it controls the right contacts. That's toggle switches. But this is a slide switch, nicer one to start with, to keep your head straight. So it's just straightforward. When the actuator's to the right, the contacts on the right are connected. We only need to use 2 of the pins. We don't need action in both directions. So if we wanted this position of the switch here to be off, we would use these 2 pins, right? Because when we push it up, these 2 pins connect, or to the right. So let's pick something. We'll pick we'll pick switching it to the right as turning it on to do this action to close. Now here is the open that I was closing with the push button. So I'm just going to use those same 2 wires. When I connect these 2 wires, the light turns on. I'm not going to use the push button. I'm going to use the slide switch. I do see, though, that the slide switch has a different spacing. These pins are just 1 node apart, so it won't work if I just put the switch right where the push button was, right? They don't have the same pin spacing. So it's, little things like that you have to pick up on, right? I mean, here is the push button. Here's the slide switch. See how they don't line up? You got the 2 outside contacts that'll never be connected together. That's easy to fix, right? Just move this over so that the connection that I will be closing is right on nodes that are side by side. And that's going to work perfectly for my slide switch. I'm going to drop it in there. Half the battle is just making sure you keep track of where the pins landed, right? When you're inserting the stuff when you're prototyping, you just have to keep track of that. That's all. So there should be 2 pins here that these wires are connected to now. Slide that switch to the right, and the light turns on, and it stays on. The push button was a momentary action. The slide switch is not. It stays. You slide it to the left, and it's off. Just that easy, right? So we're not using the other side of the slide switch, but we can if we want to. It's there. I mean, right now we're just utilizing 1 set of contacts that close and open, but there is the other contact over here. Why not turn on the other lamp with that one just to see that that's an option? So I just need to get my other lamp in the mix here, and I can bring the lamps don't have polarity, so you don't have to worry about what side you connect to. We're going to get into the spaghetti world a little bit again here, but that's just what you get if you want quick wiring with these jumpers, or if you wanted to cut your own and make it really look neat, you could. Do you see what I've done? I've brought the 3 volts to the center of the switch, which is known as the pole. The pole is the moving part of the switch. But both lamps have a connection to the 0 volt side of the 3 volts. They both do. This is my jumper to get the 3 volts. Put the batteries in series 8ing. So the lamps have the 0 volt connection already. What they need is connection to the positive side, and they get that through the slide switch. This lamp gets the positive 3 volt side when I throw the switch to connect these two. But then if I throw it to the other side, you know, the other lamp gets the connection to the positive side of the 3 volts. So you can just go back and forth. We should add that switching action to our schematic. So how would we draw it? Well, we have the single pole, which is bringing the positive side of the 3 volts here. And then we have 2 throws. That pole can either be thrown or connect to this side or this side or this side. So that's that other connection. And we just bring it to another lamp. And we've got our schematic now showing what's actually there on the small breadboard. This slide switch that we have is actually known as a single pole double throw slide switch, SPDT. If it was just a 2-pin slide switch or toggle switch, this terminology applies to any switch. But if there were just 2 pins, as in the first thing we were doing, just using 2 pins to turn on the lamp. So if you have a switch that only has 2 pins, well, that is just a single pole. The pole's the moving part. And it only has one place it can connect to. So it's only a single throw. Yeah. And while we're showing you this, we can tell you it keeps going on from there. You can get switches that have 2 poles that move together. So you could have 2 poles and maybe they only connect to one thing. Double pole single throw is just going to look something like this. These 2 poles move together and they have a single place that they connect to. So you can see a 4-pin switch. A good guess would be double pole single throw. I say guess because don't ever judge a book by its cover with components. You still have to check it out with your ohm meter, which will show you how to do that upcoming videos. But you would ohm it out, you would check it out to see what is connecting where and determine what it is that you have. You can keep going. You could have 2 poles and each pole has 2 throws. Double pole double throw DPDT, and that's going to look, again, you're going to have 2 poles that move together, but each pole has 2 places that it can connect to. So you got the 2 poles, those would be pins, and then you've got 4 other pins that are throws. So you'd have a 6-pin device. Again, a good guess if you have a 6-pin device, maybe it's a double pole, double throw. But there can be redundancy and so on, so it's not always a sure thing, but it's a good starting point. Yeah. And it doesn't stop there. You can have 3 poles, double throws, and so on. It can just keep going. More and more poles can be added. And again, though, the one that we have is a single pole double throw. That's the slide switch. We do have a single pole double throw push button too in your little box, and that's this one here. It doesn't stay on the breadboard very well, but it'll be okay to use. Just pop out the slide switch, and actually it turns out that the pin spacing on these 2 components is the same. So that makes life easy to demonstrate a momentary SPDT or a momentary push button. Just put it right in the same nodes and you'll see we have the ability to go back and forth, but not with a slide switch action. We now have the ability to stop an oncoming train, or maybe the traffic, I guess. Yes, this would stop the traffic for the train, I hope. See, you can be of some public service now. Just need to get some red filters on those, I guess. But yeah, just pushing that push button is doing the same thing that the slide switch was doing. And in the case of the push button, we can redraw that, show you what that looks like as far as a schematic symbol. For an SPDT push button, you might see something like this. You've got your actuator here that closes to this pin. This is the one, and then when you press it, the center pin in this case, again, you wouldn't want to assume, connects down here. So what you have is, if you were to label these, they would call that pin the common, and this would be your normally closed pin, and this would be your normally open pin. Normal refers to the state where it's not being pressed. So hopefully you can see just from these simple exercises that switches don't do magical things. They don't utter commands to the circuit to do stuff. They just connect. They're just pieces of metal that connect paths. And the paths can be different, you know, so you can get creative, actually, and we will in upcoming exercises where we think of something, you know, try to dream something up and then make it happen. But yeah, don't overwhelm yourself thinking switches are complicated. They're just metal contacts that open and close and provide then different paths. We'll move on to putting some resistors in the circuit, but before I do that, I just wanted to make a couple more points on this. You can see now, even though the circuit I think is simple and understandable, looking at this takes a little bit of effort. We did say, of course, you could clean up the spaghetti with cut wires, but the other point I wanted to make was, if you're presented with something like what's on the small breadboard as a finished product like this, and you need to understand it, the way you would understand it, of course, would be schematically. If you have the schematic, that's great. That's a real quick way, and that's the best way. If you have a nicely drawn schematic, you can quickly see what's happening. You've got your batteries in series aiding, and you've got your momentary push button that's connecting to either this lamp or this lamp, and you're done. If you had to reverse engineer it, just pick a starting point and move through the circuit. So I would say to myself, I see the batteries are in series aiding. I'm done with that wire. I see positive voltages brought to what I think as a guess would be the pole, but then I could pop this out and check that thing operates like I think it does. And I can see that it can be thrown here or here. I see both lamps are given the 0 volts, so they will turn on when the push button gives them the positive side of the voltage. And I'm done. But I mean, pick a starting point, pick one wire at a time, try to understand what that wire connection is one piece of advice. If you have a good schematic and you're expected to build it or prototype it, this one's very simple, so this might be overkill. But when they're more complicated, or maybe it takes a couple days to do something, you would want to maybe highlight, you know, like, and again, one thing at a time. If I'm working on this connection, I'll get a wire, I'll make that connection, and then I might just use a highlighter to highlight that's done. You know, and then I'd take this connection on next. Maybe I'm going to take a wire that connects to this common of my push button and highlight it when it's completed. And that way you can just really be sure piece by piece that it's all there. And that's more for like large projects where you're working over several days. It's hard to come into work the second day and remember exactly what wires you put in place the previous day. My hope is that these simple exercises start building your confidence somebody from the outside looking at this small breadboard as you have it here, they might look at that and think, oh my gosh, how do you even follow that? You're a genius, and I hope you can see it's just simple things, but several of them. And that's going to be what happens over the 2 years of study. Any one thing is pretty simple, a lamp, a battery, a switch. And you start putting them together and you put lots of simple things together. And so I don't think electronics is hard, but that assumes that you're going to stay organized. So it's lots of simple things, but the lots requires organization. So as long as you can stay organized, it should work out and it won't be so bad. So keep that in mind. It's even when you feel like it's too much, you're like, it's not working, and you just look at this whole thing and it just looks like a blur to you. Don't let that happen. Don't let this be a blur of spaghetti. It's not. It's simple things put together to make something maybe a little more complicated, but it's never this thing that can't be understood simply, if that makes sense. And maybe one last point before I move on. I've said it before, electronics is too much. There's too much to memorize, but it's not too much to understand. And this would be a good example of that also. Sometimes people don't understand fundamentally this very simple things that we did. So they just want to look at somebody else's circuit and say, where did you put that wire? Where did you put that wire? Where did you put that wire? And they would try to actually clone this. They would try to put the wires in exactly the same spot that somebody else, that a classmate did. So they don't understand what the circuit is, but they're just trying to mimic or duplicate or memorize. So they're like, I'll memorize that this goes here and that goes there and that goes there and that goes there. And you know what? That's just never going to work, because that's going to be thousands or hundreds of thousands of things to memorize. You'd have to memorize every point where every wire goes on a specific exercise. And it's not going to be the same exercise on a test anyway. So it wouldn't work for you. So again, I just want to really emphasize that memorization is never going to work. And understanding works quite well, and it's not so difficult. But you do have to understand what's going on, and then that solves that problem. I get questions from students sometimes like, well, where do I put that wire? Well, how do I know to put it there? And I'm thinking, I don't care. It doesn't have to go on that node, this yellow wire, but it has to go on the same node that one side of the lamp goes on. Well, which node would that be? Well, it doesn't matter, and that drives them crazy. You can pick. I could put the lamp here, but then I got to put the wire there. Well, why do you have to put the wire there? You get the idea. So the lack of understanding will drive you crazy. You must understand the simple things, and then you can build it however it best lays out. And that's sort of the open-ended part that sometimes frustrates students, because if they don't understand it, they just want to be shown. Show me where to put the wire. You're the teacher. I'm asking, and you won't tell me where the yellow wire goes. And I'm like, it can go wherever you want as long as it goes onto the lamp. But so round and round it goes. So yeah, belaboring that point, but it happens, and it's the beginning of the end if you try to just memorize stuff without understanding it. So now let's reset the circuit back to a simple 3-volt source and a switch and a lamp, and maybe we can quickly review how to do that. I see the 0-volt side is already connected to the lamp, so I can give the lamp the 0-volt side of the 3-volt source. Done. I need a switch. I'll use this little slide switch. I only need to use 2 pins, so I'm going to use 2 pins maybe on the right side. That way I'll turn it on when I slide to the right. I wanted to mention this. The switch, I have to put it on oriented, sort of left to right. You might think, oh, but I want to do it more like I see on the switches on the wall, where I can push the switch up to turn the lamp on and down to turn it off. Well, what's wrong with trying that? Let's see here. I mean, it'll fit on the breadboard like that. So Can you tell me why that won't work or why that could work? Yeah, not all things are an option. So remember what we said about the breadboard layout. If you try to put the switch oriented vertically, it's not an option because all 3 pins go on the same node. So what you've done when you push it in like this vertically, or orientation, you just connect all 3 pins of the switch to themselves. And so don't do that. But I mean, that happens. I mean, people get stuck on the fact that they want the switch to be oriented this way, and the breadboard just doesn't give you that option. So you need each pin of the switch to be on its own node, and so the only option is to orient it horizontally. Okay, so we got to do that. Put it on there. Now you have to know where those nodes are. Where is my switch? And it's a little hard sometimes when it's probably here, here, and here. But I could always pull the switch out slightly to spot that. I'm going to try my best to hit those spots. If I don't, I'll come back to them. That's probably the thing that I got wrong. But yeah, let's see here. I think... Oh, I'm already looking at my other switch, so I took a little cheater glance at the other switch, and it looks like they're just spaced a node apart. So this looks like I have the right spacing, but let's see if I'm right. Okay, so there we go. So my lamp turns on. If it didn't, I'd be asking myself, am I off by a node, right? Because if I put this yellow wire over here like I was originally going to, I'd be off by a node. Like I say, you can always pull the switch out, take a look. If you're not sure. So we've got that built now. And let's try adding a resistor, because I want to introduce the schematic symbol and just maybe the basics of what a resistor is. So the schematic symbol for a resistor is just, little jagged lines. Maybe easy to remember. It just looks a little more difficult to get through, right? Let's put one in anywhere in series. So it just means we're going to insert some more resistance into the path. It will make the path more resistive, so I think you can predict what will happen if I increase resistance in the path, but I didn't change voltage. I still have only 3 volts of pressure pushing. I do have the lamp's resistance, and now I'm adding more resistance to the path. And in fact, we'll use those little 10 ohm resistors. So I've added 10 ohms of resistance to the path. Let's see what happens. I think you can predict, right, with Ohm's law, if you increase the resistance and don't change the voltage, current's going to decrease. We'll see that played out by the lamps going dimmer. So let's try it. So you have to find the resistor you need. It's going to be a brown, black, black stripe. It's a 1 and 0, and then a 0 for the multiplier. And you're going to find a place to put that on the breadboard. You can bend the leads. And then I want to put it, well, according to the schematic, it belongs on the low side of the lamp. So the lamp no longer gets a direct connection to 0 volts. It's going to get there, but it's going to have to go through an additional 10 ohms. So I can do that here. I'm just going to put it right there. That's a nice easy place. And do you see it's not on the same node because of this divider. So I hooked the 10 ohm to this node, and then it has its own node on the other side. The resistor, and now I'll take that other side of the 10 ohm resistor to 0. I don't know. I can't tell. Is it a little dimmer? Yeah. I mean, I know it has to be. How much dimmer? Well, I can jump back over and give it a straight shot. Yeah, it's kind of hard to tell. Makes me think I want to add more resistance. So I can do that, right? I could add 2 10 ohms in series. Or, I mean, you could grab a higher value resistor. I could just put 2 10 ohms there maybe. So I'll grab another 10 ohm. And again, it doesn't matter where you put it, but I mean, you got to find some place to keep yourself organized. So I'm going to take this 10 ohm, like that. I'm just adding, I mean, I got a path now, you know, through the switch, through the lamp, through this resistor. I hooked onto that node there. And then on the other side of that resistor is here, so I'm going to take that one. Let's see if 20 ohms makes it significantly dimmer. I think so. You kind of have what's called a stepped attenuator here. You could take, there's 20 ohms added to the lamp, there's only 10, and there's none. I know it's a little hard to tell, especially on the camera. You know, I mean, you should we keep going? Let's put another 10 ohm, and we just put it in like this. We now have 30 ohms, and I'll draw it in a minute. I'm just trying to make that lamp dim out. Maybe 10 ohms is not enough. I think maybe we go with 100 ohm resistors. So let's retool and do that. So I've changed out the 10 ohm for a 100 ohm resistor, and I like that better. I can see a dimming effect more obvious. The 100 ohm resistor that you have to find is going to be brown, black, brown, and a gold stripe tells you 5% tolerance, which we'll talk about down the road. But brown, black, brown, again, the colors are going to be, brown represents the number 1. So we have, I'll put it over here, 1. And then black is the number 0. Those are the first 2 digits. And then we have another brown stripe, which represents 1. And that is, that's actually the multiplier. So it's actually times 10 to the first. Or another way of thinking of it is times 10. Or another way is just saying that's how many decimal places you add or take away if it's a special multiplier. So long story short, you got brown, black, brown, which means add 1 more 0, and you get the 100 ohms. Or add 1 more decimal place. We'll review that upcoming theory sessions and stuff. We'll get the whole color code put out there for you. So the 100 ohm definitely shows a significant dimming, I think. So, I mean, here I am with the 100 ohms included. I can go to the other side here and just not include the 100 ohms. There it's bright, and here it's dimmer. And you'll see that. I could go ahead and add a second 100 ohm if I want to, and I'll just do the same thing we did. I think this will, of course I know this will dim it out more. Let's see how much. It's kind of experiments you can do, right? So I'm going to take another 100 ohms, and then now the circuit has to go through both of those. So I've added 200 ohms to the path. Yep, very dim. And again, I have sort of that stepped attenuator thing. Here's my path with 200 ohms added. Now I've only added an additional 100 ohms to the lamp's resistance. And here I've not added any extra resistance to the lamp. So I can see I can control current with these resistors. Full current, less current, less current. That's one thing resistors are good at, right? I mean, I could control the current by the voltage, by controlling the voltage too. Yeah. And while we have 200 ohms in the circuit, I can't resist letting you have a little preview of an upcoming video that we'll do. If you can find this little component, this is known as a potentiometer. We're actually going to just use 2 of the pins. And when you just use 2 of the pins of a potentiometer, you're really using it as a variable resistor. But we'll talk about all this, but I just wanted you to see it because it is kind of fun. And it relates that you got to find the little blue potentiometer that has the numbering 201 somewhere on it. Because I know that I gave you a 200 ohm potentiometer. 201, find that one. That's important. You have to have the right value. And what that's telling us is you have 20 and then times 10 to the first. So this is a 200 ohm potentiometer. Now, like I said, we'll do an upcoming video that really explains all of this component. There's 3 pins. We're just going to use 2 of them because I can't resist giving you that little preview. You have to use the center pin, and then it doesn't matter. You can pick one of the outside pins. It doesn't matter. If this works for you, or you can skip this if it doesn't work for you. What I want to show you is those 200 ohms that I got from the 200 ohm resistors. I'm now going to put in place of them a variable resistor. So this is what it's going to look like. It's actually a total of 200 ohms, but I can vary it. And it's very much like a valve in a plumbing system. So if you have a valve that you can open or close a certain amount, you can control the flow of water. I mean, that's exactly what we'll do here, but we'll control the flow of current. So I couldn't resist showing it to you. Let's get it in place if we can. You're going to just use the middle pin and one of the outside pins to put that into the circuit. So I don't know if it works for you, great, or you can wait till I actually do the whole video on potentiometers and variable resistors, but it's kind of a fun one. So I'm going to need to take the other side of that lamp through the variable resistor, which will be 2 pins of the potentiometer. So it doesn't matter which outside pin necessarily. There's some things I can talk about later. But there I'm on one of the outside pins, and now I am on the middle pin, and I'm going to bring that to ground. Just wanted to show you that. Let's see what happens. To adjust the variable resistor, you simply use a small screwdriver right there, a small flathead, and then you can spin that. Don't turn too tight. I mean, there's a limit to where it can go. Don't break it. But now you can see when I rotate it, the resistance varies between 0 and there I'm at 200 ohms. I can tell because the lamp's at its dimmest. So you can see that. And I can see that when I turn this, if I turn it counterclockwise, the lamp grows brighter, and when I turn it clockwise, the lamp grows dimmer. That's not quite as intuitive as I'd like. I mean, we're probably used to turning things to the right to turn them up brighter or more volume or whatever. So usually we associate an increase with turning it clockwise. That's an easy fix. I will just take the wire that's connected to the one outside pin. I'm going to use the opposite outside pin, the other outside pin. And now I've changed the direction. You still need the center pin to be used always, but I changed it to the other outside pin, and now look, it's working more intuitively. I turn to the left or counterclockwise for dimming, and I can turn to the right for brightening, probably more what we'd be used to. So this is a little preview of using a potentiometer as a variable resistor. You just use 2 of the pins. The center pin you have to use, and you can pick which outside pin you want to use, and that determines how it operates as far as clockwise and counterclockwise, meaning which one's associated with increased resistance or decreased resistance. But that'll definitely be its own little video. There's enough to talk about with using it as a potentiometer and a variable resistor. So we'll get that in the future. But it's fun to play with a little bit. And in this context, not a bad introduction. Let you see it control the resistance that you're adding to the circuit. And you can see the arrow, the diagonal arrow through the resistance is just the schematic symbol to tell you that there's 200 ohms from here to here, and it is variable. It's adjustable. And again, with these simple circuits, maybe it's worth taking the time after you've built it, sort of take a step back, see if it works, to review it. You know, can you follow it? Can you trace it? I mean, you might have done the connections one at a time, and then when you take a step back or step away from it and come back to it, can you double check it? And you just go wire by wire, connection by connection. I mean, first you would make sure that your schematic makes sense. That all looks good. And then you look and say, is what's built on the small breadboard the same thing as what's drawn? That's, of course, important. I've got the batteries connected in series 8. I see that. I see the positive side of the 3 volts coming to the pole of a slide switch. I see the throw to the right, then being connected to a lamp. And so far, this is all working, right? That makes sense. I see the other side of the lamp that needs to be connected to 0 volt side of the voltage source. I see it's going to get there, but it's got to go through a 200 ohm variable resistor. So here it comes, and it's coming to one side of the variable resistance, and then the other side of the variable resistance is bringing it back to 0. See? And I worked my way through the spaghetti, wire by wire, connection by connection, following the flow of the circuit. And don't try to just stare at it as a whole and see if it looks right. I mean, you could be staring all day long, right? So yeah, do that little review. We're going to reset and do just maybe one last exercise just to show you now, even with this real simple circuit stuff, you can get creative and sort of challenge yourself. So let's reset this. So let's try to be a little creative, and you can try your own things. Just, I would again say, keep one finger on the batteries. If they're getting hot, your creativity is not going the right direction, right? It's going in a bad direction. So you don't want to create shorts. You don't want to create high current paths. So you have to keep a lamp in the path, not just a wire. That would be too high of a current, and so on. I mean, most of the parts I've put together for you, they'll work with each other. They're compatible. So, you know, obviously I have a 3 volt lamp so that it won't get burned up. But I mean, you can certainly try some things on your own, see what you can come up with. Let's do one just to get you sort of the idea of what I mean by be creative. I mean, we know switches just are devices, it's components that like pick different paths. So I have an idea to vary the brightness of my lamp by either applying 1.5 volts, which I would pick off here, right? If this is my circuit common, why don't I do this? Why don't I take this out to a lamp, to one side of a lamp, right? And I could say to myself, I know if I apply 1.5 volts to that lamp, it'll be sort of half bright-ish. And I could apply 3 volts, the full 3 volts to it, and it would be sort of full bright-ish, right? A switch can do that. A switch could pick to connect this to here or here. What does that sound like? Sounds to me like a single pole that gets thrown here or here. So here's my pole, and I know the switch looks backwards. That's okay. So I'm going to have my single pole, and it'll connect here, or here. So I've got my single pole double throw switch. And this is the thing, you know, pencil and paper, just do your sketch first. I'm not a big fan of trying stuff out just by plugging stuff in and out and here and there, and whoops, the batteries got hot, must have put something in the wrong spot, and let me try it. Don't just do that. That's more the hobbyist approach. Like, I don't know what I'm doing, but stuff's happening. Hey, a light came on. Hey, that's cool. Hey, look, I got 2 lights to come on. I mean, I've had students there's always somebody that more than one, just happily trying stuff. Try this, try that, try this. And sometimes when they want to show me what they got, they'll be, look, I got it to turn on and turn off. And I'm thinking, okay, why is your battery burning up? Because there's more than one way to turn a lamp off. And one of those ways that's a bad way is just put a dead short across the battery. All the current flows through the wire because it's so much easier. So the current's going to flow through the wire, and not much at all is going to go through the lamp. So yes, you turned it off. That's called a shunt path. And you basically just killed the circuit by shorting it. And that's not a good way to turn a lamp off. So, yeah. So, I mean, that's why you don't want to just plug things around and just do a visual inspection. Like, my lamp's going on and off, and I'm thinking, yes, but your battery's burning up. So, yeah. So, okay. So do the drawings, sketch them out. Make sure your drawings make sense to you. And from that point, wire what you've drawn. And you'll be doing it the right way. You'll be doing it the technician way. Still keep a finger on the batteries in case you make a mistake. Not a bad thought. But look, I've got a lamp, and it should be able to be switched by a single pole double throw switch at between 2 brightness levels. I've got other components, so I mean, if I want to, I could get another lamp involved. I mean, just whatever, just think of something and then try to implement it. And that's the order I'd like you to do it in. Don't just, like I say, the previous thing I was talking about, don't just slap stuff on there and then say, oh, it does stuff. If we were in person, I know that I get called over to someone's bench. Hey, look, Mr. Evans, look what mine does. But they don't understand it. Like, do you know why it does that? And like, no, but I like that I did it. And I'm thinking, yeah. Again, so make sure you understand what you're doing, and that comes from the design, right? I'm thinking to myself that I know what I want it to do here. And then I'm trying to figure out how to implement it, and then I'll wire it. So I thought to myself, I can have a brightness select here, right? That'll pick the brightness. And then this lamp will always show me that brightness. And then I can just use a momentary push button to flash this lamp at the prescribed brightness. I mean, just came up with that just for one example. So then once you have something and you understand it and you've drawn it and it looks right to you in the drawing and it looks like, yes, that will do what I want or what I designed, now just wire it, right? And again, don't try to think of it all at once. Take it connection by connection. So I need to connect the 2 batteries in series 8. Well, that's done here. Okay. What do I want to do next? I don't know. Pick a starting point. I could take that midpoint between the batteries and bring it to one of the throws. Now remember, for the slide switch, the throws are the outside pins for this slide switch. I mean, you don't want to assume that, but you could always check that again to find out what the pin out is. And we'll do that with our own meter and stuff in upcoming exercises. But, and I'm going to use, I'm going to use the left, I'm going to put it on, horizontally, I have to. And I'm going to make the left side the low voltage. So, because to me, it seems just like if I throw it to the right, I'll get brighter. For some reason, that seems like it's intuitive for me. So I put it on the board. I can keep an eye sort of on, before I press it in, I can keep an eye on those pins where they are. So I need to make that connection from the middle of the batteries. Where's the middle of the batteries? It's right here. It's this blue wire. Well, where should I connect it? Should I connect it to this rail or this rail? This red rail here or this blue rail? What do you think? What is your answer? It doesn't matter. That is the correct answer. Doesn't matter at all. So they're the same point electrically, right? I've connected them with a piece of metal, so they are the same point. So I don't care. I'm going to take it here, and I'll put it on the left side throw of that slide switch. Okay, I've got that wire done. If I had a highlighter and on a piece of paper, I might even highlight that. You know what? I've got this connection and I've got this connection right here. Those are done. And okay, I need the other, while I'm thinking about throws, right? The throw to the right is a straight connection to the 3 volts. So, right, and that makes sense, right? I mean, one of the throws the switch will be connecting to 1.5 volts. And the other throw, it'll be connecting to the full 3 volts. So there's my full 3 volts up on this rail, remember. Yep. So let's see if I can get to that node. You know, it's there. Okay. Well, and again, if I had a highlighter, you know, I'd highlight that one. That one's done. The pole is what's going to be connected to the lamp. So I'm looking for to make this connection. Now, yes, there's more to that, so I'll get that in a minute, but I'm going to do one thing at a time. I'll use yellow. That seems to be easy to remember that that's my lamp. So, I mean, you can make some sense out of the colors you choose. I can press that slide switch down in now. I have it sort of figured out where those pins were. I'll just put this on a node, and then I'll put my lamp there. So one side of my lamp, and again, remember the diagonal orientation works good for the lamps. Drop it right in there. That connection's done. I might finish this lamp. I just kind of want to complete that, you know, somehow before I do this other push button lamp. I can see the other side of the lamp while it's in my head. I just put that lamp on there. It needs to get connected back to the 0 volt side of the 3 volts. And I'll use a black wire to do that. So I get the other side of the lamp that's sitting on this node, and I'll bring it right back to the 0 volt side of the 3 volts. And actually I could test that much. You know, that's not a bad strategy. There's my lamp. I see that I wiggle it and it turns on and off. So I'll keep that in the back of my mind. I'm not so sure that that lamp is reliable. But so if you have one of those lamps, just make note of it. Like there, I can get it to be off. Oops, it's on. It's dim now. So that tells me I've got a bi-pin lamp that might be a little weak in its connection, you know. That's what I'm thinking. I'm going to switch to my other bi-pin lamp. I have 2 of them there for you to use. I'm going to maybe see if this is maybe my more reliable one. Yeah. Yeah. That one does not seem to have the same problem. So I'm starting to narrow in on that one bi-pin lamp as a little iffy. And I can test this, and that's a good strategy. Like maybe don't try to hit a home run. You'll hear Schreiner say that a lot when you get into programming and stuff. Don't try to put it all together, and I concur. I say the same thing. Maybe test it as you go. So let's see if this much of the circuit works. And in fact, it does. I can take it from sort of half bright to full bright with my slide switch now, which is just picking paths, just connecting paths, different paths. Okay, cool. So that's all working. You know what? If I continue and it stops working, I know that my problem is in here in the new part. So that's why I like that I tested it already. I know that much of it works. Now we're just going to get a push button involved. So let me find one of those. And again, I'm sort of building it left to right on purpose because why not? Makes my life a little easier. I mean, the schematic's drawn left to right. And by the way, schematics are always left to right, top to bottom. That's something you definitely want to get in the habit of doing. Circuit layout can be whatever works best for the board, but schematics are always left to right, top to bottom. But since I'm able to, I'm making my life easy by sort of following the same flow as much as possible on my breadboard. So I'm gonna put the push button sort of to the right because I have room. I mean, I'm not gonna make myself go all in circles trying to follow it on my breadboard. So put that push button in place. Now I need another lamp that's controlled by the push button. Maybe I'll get that sort of on my board and then I'll see what I've got here. Okay, well, here's a simple one. I know one side of the lamp gets connected to the 0 volt side of the 3 volts. So let me just do that. Okay, and the other side of the lamp is right to one side of the push button. So let me do that. Right. All right. I think that's the right node. And if not, I'll come back and double check that if it doesn't work. Last wire is the other side of that push button. Where is it going? It's actually going to the same node that this side of the lamp is on and that the pole for the switch is on. The pole is the center pin of that slide switch. So that's the node I'm looking for. And I can get there. Just use a blue wire. I'll just see what node's available. Okay. So here's the thing. I got choices, right? And that's fine. I mean, this is the one side of the lamp, so I could hook it here. I could also hook it over here, which is the same point. You know, it's the middle pin of the slide switch. If I can not block the light there. So I have that as an option for where I connect this, or I could connect it here. They're the same because of this yellow wire. Do you see this yellow wire connecting that side of the lamp to the middle? So anyway, and sorry if I'm so going so slow. For some of you, you might be like, yeah, you could speed this up. But I know that some of you, it helps when I'm really talking it through like that. So that's, that's why I'm doing it. I put it right at the lamp. Schematically, it seems to be, easy to follow there. But either one would work. Okay, let's test it. So I have brightness select, and the brightness is indicated here, and that's the brightness that this lamp will fire up at. Yep. Looks like they're twins when I push that, which is good. And that makes sense, I hope, to you, that because the lamps are going to be put in parallel. Whatever this lamp's getting, this lamp will get when I push the push button. Makes sense. Now I'm going to choose the other brightness. I'm putting 3 volts there. Indicator tells me you got 3 volts sitting there ready to go for your other load that this lamp can represent whatever I wanted to apply the voltage to. I'm applying 3 volts to it. But see, I get a preview. Now you're going to apply half power to it. And there I'm doing it. So you can make your own clever little circuit, but hopefully you do it pencil and paper first and inspect it. Make sure you're not going to burn up your batteries or damage your switches. If you put a dead short through a push button contact or a switch contact, they'll get damaged. The little pieces of metal that are connecting can actually get welded together from too much current. So it is possible to damage these parts. So do your best to think it through first, not create any short circuits, which are just 0 ohm paths, like a wire that would just, connect. For example, this would be bad, right? If somehow I had that connection, as soon as I turn the switch on either direction, I'm just letting current flow through a low resistance path, very low, close to 0 ohms, high currents, and might burn up the switch and so on. Yeah, see, have some fun. See if you can invent something. It can be simple at this point. That's really better than going for something elaborate that you don't totally understand. That's not a good goal. So make sure that you just stay within what you understand. That's the important thing, and then build out from there. So, but maybe you come up with something interesting, something amusing. And hopefully all the parts stay intact. We did very little measuring in this exercise. We did a little voltage measurement, but that'll probably be the next thing that we zero in on. We'll get your multimeter out, show you how to measure voltage, current, resistance, and then we'll tackle simple circuits like these, but we'll actually get in there with our meter and we'll have a look at what is the current actually that's flowing. We'll measure that. We'll measure the voltages. We'll measure the resistances of our components, and that'll be a big part of the upcoming videos. We'll get into the actual measurements of these circuits. These first two like I said, the whole point is just to get you kind of oriented on how do you put together a simple circuit on a breadboard, or even what is a circuit for that matter, and what are some of the components, symbols, as far as schematic symbols. So yeah, it's been very introductory, but I think that's smart. And then we'll take this and we'll do all the technician type stuff in upcoming videos. This was more of a hobbyist, but an introductory look. So that's fine. And then we'll do measurements and calculations in the next couple videos. That's probably where we'll head. Okay.